Before we even start talking about some hardcore hacking and creating real viruses, you need to know how the exe file is working. It's very simple, really. An exe file, like any other file, has specific file format. If you know this format and how to read it, you will be able to do anything with exe files. From DLL hooking by stealing function arguments to infecting apps, everything starts here. It's absolute basic you need to know to become a real hacker. Don't waste your time watching videos like 15 Linux commands every hacker must know or some other crap. Every hacker must be able to create their own tools in multiple languages. So, if you need to know some commands, that should be names of your programs. You want to become the hacker without programming? It's like trying to run without your legs. Good luck! In this video, PE header and how it really looks. Constant part of exe and variable part of exe. Locating PE header. Hexprint procedure. Reading file header. Reading optional header. Reading every section in file. This is how Wikipedia shows us the PEX header. For someone is just starting their adventure with hacking, it looks quite strange. This is how Oli Debugger shows us PE header. And in this video, we'll recreate this. Oli Debugger is free and very powerful tool in debugging, cracking and changing apps. Personally, my favorite. It doesn't look like a toy for retarded child, unlike Ada. This is of course my opinion. This is how exe file really looks like. We will recreate this in our app. And of course this header is also header of these file types. So, after watching this video, you will be also known how to use these file formats. Every exe could be split into two parts. Constant part, from file start to end of PE header. Variable part, starts from section headers, then contains each section raw data. Exe file could contains many sections, that means many section headers and raw data. That's why this part of exe file is variable. I'm added example section to our analysis app that you could see how it's look. And of course GCC compiler adds many of weird sections to file, which you could see in the self-read mode. Our app to analysis will be this simple hello world written in FASM. Like you can see, it has three standard sections: data, code and import, and one example section for better understanding. This app is perfect for this example. This image from Wikipedia tells us that PE header will be placed under 3C offset from file start and nothing else matters. If we want to read PE header, we have to read offset on this offset. Let's see how to do it. Every example will be in C. First, we load app to memory, then read what's inside. This application argument is the name of the file to read. Without the argument, it will use self-read. Loading file into memory is explained in the C virus example. That link you could find under this video. PE header is located under offset 3C. If we have file in buffer, we can read that byte like a standard char table byte. So first we will be testing self-read, then app to analyze and comparing results to Oli debugger. Let's compare it to Oli debugger. Everything is fine. Hexprint is very useful everywhere where you need to compare data in our app to memory of other file. I've created this procedure during writing a kgen to get sure that my app doing the same thing as app that I'm cracking. I've planned a series about how to create kgen, but because of YouTube policy, I can't finish this project. Hexprint is a very useful procedure that helps us check the readed bytes for comparison with the debugger. Let's check first kilobyte of readed app. This is how it's look in our app and how it's look on debugger. We have exact same output. This is how p header looks in constant form. It could be split into two parts, and of course it could be read just by the structure called image anti-headers. And this example will be at the end of video. But for now let's complicate it a little bit more and read all these structures separately, starting from image file header. Here is declaration of this structure. To locate this structure we need to do some math. Under offset 3c we have offset to p header. In fact it's also offset to image anti-headers. And like you could see, p header starts from p signature, which has 4 bytes. So we have to add this value to get offset to image file header. Members of file header. Quick look at members of the structure. For more information, look in video description. From this structure, we need only number of section to read sections in future. Here we have declaration of the structure. Now we need to fill up this structure with data. Maybe I will surprise you now, but it can be done in one line. To do this, we need only one function, memcopy. Let's see how it's look. Like you can see here, we take offset of start image file headers. It's p header offset plus size of p signature. When we copy this into structure address, we will fill up this structure with data. This method is also very useful in creating TCP/UDP packets in row of sockets. In some future videos I will show you what I mean. To see this structure, we're gonna use procedure called print file header. So, let's check results and compare them to debugger. Like you see, values are the same. It was self-read. Now test Hello World. Like you see, we have the same exact output as debugger. This is how the structure looks. It's end of constant part of exe file. To locate the structure, offset to optional header is previous offset plus size of image file header. This is how it looks. At the end of this structure we can see something called image data directory. It's another structure, and it's declared 16 times. And that means that printing optional header will be a little bit more complicated than printing file header. This is how image data directory looks like. This structure is declared 16 times, so we have to read it in loop. Members of optional header. That's a pretty long structure. I will only talk about few most important members of this structure. More information you will find out in video description. The last one is interesting. I will explain you why in next video. Let's see reading optional header in practice. First, structure declaration. Then we have to fill up this structure with data. It's task for a mem copy. Let's see how to print this structure. It's simple. We are doing everything like in previous example and first part. In second part, we have to read 16 structures declared at the end of optional header. It could be done in one for loop, like you see. Let's check results of self-read and of Hello World app. First, self-read. We have the same values. Now our Hello World app to analyze this. Also same values, so optional header is read correctly. Section header as first part of variable exe part. Like you see in previous example, number of sections could be different for each app. This is how section header looks like. Size of the structure is constant. But we have to know how many section headers are in file. This information is in image file header. Reading section header will be in for loop, where counter will be number of sections, step will be size of the structure. Members of section header. To be honest, we only need virtual size and characteristic for future usage. Full description of section header is in video description. Here is declaration of the structure. We have many sections, so we have to use for loop to read every single section header. Counter will be number of sections. To fill up structure with data, we are gonna use memcopy. But first we have to know offset to the structure. Its previous example offset was size of optional header. If we have that offset, we have offset to first section header. There will be few section headers in every exe file. How to locate them? We have to add size of section header in every memcopy count till end of structures. Then we print in section header. Let's see how it's look. First, self-read. We have the same values. Now our Hello World app to analyze this. Also same values. To remind you, image anti-headers looks like this and contains every structure from previous chapters. Here is structure declaration. Here we are filling up this structure with data, then printing it. Let's check how it's look and compare to the debugger. As you can see, we have recreated the debugger output. Everywhere we have the same values. Let's test our Hello World app. Also, we have the same output. So, this is how exe files looks inside. It doesn't that scary if you know how to read these file types. Of course, it isn't last video about exe files. Will be much more. This skill is absolute basic if you want to become a real hacker, in my opinion. It's much better for a start than using nmap, for example, because even if you find some vuln app, how do you want to write exploit if you don't understand how EXEs working? You have to start walking before you start running. Thanks for watching! Stay safe and always pay attention to file extension.